is vector OA, right? This is vector OA. I am scaling this vector. I am just scaling this vector, and at the same time I am rotating this vector. Okay. Today we are going to understand what exactly these eigenvectors and eigenvalues are with a different analogy, with a very different perspective. Because linear algebra, it is one of the very important topic when it comes to any competitive examinations. Yet it is a very simple topic, but we must have to clear our basics, because as it is one of the easiest topic, we don't want to take any risk in examination to skip this problem. Without wasting further time, we will understand what exactly these eigenvalues and eigenvectors are with a very different perspective. For this, I will take an example of matrix A. Say matrix A is 1, 2, 2, 4. I have another matrix, say X. I will say 1, 1. Okay. Now, I will simply multiply these two matrices. Say A into X, and it will become, it is just a simple multiplication of two matrices. So it is 1 into 1 plus 2 into 1. So it is 1 plus 2, 3, and 3 comma 2 plus 4, that is 6. Simply I have multiplied these two matrices. And now the interesting part. What I am going to do now, I will plot this on my xy axis. Say this is your y-axis, this is your x-axis. So if I plot this point 1 comma 1, so simply it will be here, say point A 1 comma 1, and if I draw a position vector from origin, so it will be OA. This is your position vector of point 1 comma 1. Similarly, if I draw this point 3 comma 6, so it will be somewhere here 3 comma 6, right? And if I draw a position vector of this 3 comma 6 point, so it will become, say, point B, and this is the position vector of point, and this is the position vector OB, right? Listen carefully, this is a very important part. So what I am doing here, this is a vector OA and this is a vector OB. I am scaling this vector OA, right? I am scaling this vector, and at the same time I am also rotating this vector. Okay, see, I will show you with an example. Yes, listen carefully, this is very important. This is vector OA, right? This is vector OA. I am scaling this vector, I am just scaling this vector, and at the same time I am rotating this vector. Okay, so what I did, I scaled this vector, and at the same time I rotated this vector at an angle theta. So this is important. So this is important, at an angle theta. So what actually I am doing here, scaling plus rotating, right? I hope you have now understood this. Now I will take same matrices A, that is 1, 2, 2, 4, but I will take different vector here, say 1, 2, right? Again I will do same thing, AX is equal to, so it will become 1 plus 4, that is 5, and 2 plus 8, that is 10. Okay, simply I multiplied these two matrices, so AX is equal to 5, 10. I will plot these vectors on my x and y axis, right? So if I plot a vector, a position vector for this point, so simply I will get 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So simply if I plot this point 1 comma 2, so it will be here, right? 1 comma 2, say point A. And if I draw this and if I draw a position vector for this point, so it will be 5 comma 10. So 1, 2, 3, 4, 5 comma 10. So it will be somewhere here. Say point B, 5 comma 10. Listen carefully. Now a very interesting part, that is what I am doing here. Listen carefully. What I am doing here, actually I am scaling this vector. Okay, this was my original vector OA. right? This was my original vector OA. Now I am scaling this vector up to OB. Okay, this is simply, I will show you with an example. So this was my OA, right? I'm just scaling this vector, right? I'm just scaling this vector, but this time I'm not rotating this vector. So I'm just simply scaling. Pure scaling is there. There is no any rotation of this vector, right? So I can say here pure scaling, right? Now listen carefully. This is what actually I want to tell you. Okay. For this vector, I am scaling this vector without any rotating, and this is the eigenvector. This is actually the eigenvector. So simply I can write, and vector undergoes pure scaling without rotation is called as eigenvector, right? So my vector OA is undergoes pure scaling without any rotation, and this is what eigenvector. And listen carefully now, this is again a very important point. A scaling factor is called as eigenvalues. Okay, so a vector which undergoes pure scaling without any rotation is eigenvector, and by which factor it has been scaled is called as eigenvalues. I will show how exactly the scaling factor works and what exactly the scaling factor or the eigenvalues. Say we have AX is equal to 5, 10, right? What I'm doing here, I'm taking 5 common from this row, right? So we'll have 5, 1, 2, right? What is this 1, 2? This is actually our vector X, right? So simply I can write AX is equal to 5 into X, right? So as you can see here, this is in the form AX is equal to lambda X, and this exactly the definition of eigenvectors and eigenvalues. A equation which satisfy Ax is equal to lambda X, where lambda is any constant, and often we call this lambda as eigenvalues. Okay, so lambda are the eigenvalues, and which satisfy the equation Ax is equal to lambda X are the eigenvectors. I will show you here. Listen carefully. If lambda is equal to 2, then Ax is equal to 2 into X, right? So Ax is equal to 2 into 1, 2. So Ax is equal to 2 comma 4, right? Now listen carefully. If lambda is equal to 5, say eigenvalue is 5. So simply what we are doing here, we are scaling this vector, that is OA, with lambda is equal to 5. So we will get OB. Okay, we have scaled this vector with lambda is equal to 5, right? If I scale a vector with lambda is equal to 2, I will get Ax is equal to 2, 4. So if I draw this point 2, 4, it will be somewhere here. Say point number D. Now listen carefully guys, this is very important. How? If I take lambda is equal to 2, I am scaling this vector, I am scaling with this vector with a factor 2, right? So I will get OD. If I scale this vector with lambda is equal to 5, I will get OB. So this is what exactly the eigenvalues and eigenvectors. So I hope you have understood now what exactly the eigenvalues and eigenvectors. So some important points. This is the first very important point. A vector undergoes pure scaling without rotation is called as eigenvector. The scaling factor is eigenvalue. This is the third most important, where Ax is equal to lambda X. This is the equation which satisfy eigenvectors and eigenvalues. So now I hope you have understood what exactly this eigenvectors and eigenvalues are with this particular analogy. I will give you an example here, right? This is you, okay, and this is your preparation, any exam preparation. right? And this is the success, right? And say we have failure also. Now listen carefully, this is very important. Just an analogy, right? Just an analogy. You have to understand what exactly what exactly these eigenvalues and eigenvectors are trying to say. See, this is original vector u, and you are preparing for any particular examination, say GATE or IES or any competitive examination. So if you scale your preparation, listen carefully, if you scale your preparation without diverting, without rotating yourself or without diverting yourself, you will get success, right? Scaling your preparation with a proper direction will lead you towards success. But even if you enhance or scale your preparation, but somewhere you diverted from the exact preparation, you will meet failure. So be an eigenvector, scale your preparation without diverting, you will get success. Why I gave this example, because guys, this is the high time for you, because just due to corona everything is just messed up. We don't know what exactly is going to happen in next couple of months, and so but for any examination in future you will not get this much of time. So this is a very crucial time for you to enhance your skill, to understand and to clear your basic conceptual knowledge. So I hope you understood this. Share this with your friends so that they can also understand what exactly these eigenvalues and eigenvectors are. Subscribe to our channel, hit that bell icon, and join our Telegram family. I have provided a link in the description, so you can join our Telegram group where we have almost 3000 plus members, where you can share, where you can discuss your doubts. I have also provided my contact details, so directly you can call me or text me if you have stuck with any difficulties regarding this technical syllabus of any particular examinations. All the best and take care. Thank you.